Hello friends, welcome to online engineering. In the today's lecture we are going to start with some GATE questions asked in the previous years on the basis of effective stress, total stress and pore water pressure. To start with, I am taking the first question from the GATE 1999. The question will be visible on your screen and the question was from GATE 1999. This question is saying that a river 5 meter deep consists of a sand bed with saturated unit weight of 20 kilonewton per meter cube. I am writing down the given data. Gamma saturated is 20 kilonewton per meter cube, whereas gamma W is 9.81 kilonewton per meter cube. The river depth is 5 meter. And it is asking that the effective vertical stress at 5 meter from the top of the sand bed is. The answer is in kilonewton per meter square. So first of all we have to plot the soil profile as stated in the given question, as it is said that there is a river. So first of all the topmost layer will be of the water, and that as it is mentioned there, the depth of river is 5 meter and below that there is a sand bed. It is asking us the effective stress at a distance of 5 meter from the sand bed. Fine. So to start with and to calculate the value of effective stress, I am describing you about all the three type of diagrams that were the total stress, effective stress and the pore water pressure. But to start with, first of all I am drawing here the diagram for the total stress. It is represented by sigma, and we also know that it is the stress acting on the soil in the downward direction. Downward direction stress is taken as positive, whereas upward direction stress is taken as negative. So we can say that at the top here the pressure is atmospheric and hence it can be written as 0. But as we move down in the water layer, the pressure will increase because of the weight of the water. And we all know that the weight of water will increase by a unit weight of gamma W. Hence we can say that for the first 5 meter the effective stress will increase at a rate of gamma W, and that is 9.81. So you can easily say that the value will increase linearly from 0 to a value of 5 meter into 9.81 kilonewton per meter cube is the value of 9.81, whereas 5 is in meter, and hence the unit of this product will be kilonewton per meter square. That is the value of stress. Whereas below the river sand is present, and as all the voids of the sand are filled with water, you can say that the weight of sand will increase by gamma saturated, and hence you can easily say that after this the weight of water layer lying above the sand layer will remain constant, and as we move down in the sand layer the stress will increase because of the weight of the sand, and hence you can say that after this there will be an increase in the total stress, and that will be due to the weight of the sand, which will increase by gamma saturated. As we are moving down to a total depth of 5 meter in the sand, you can say that the stress will increase by gamma saturated into 5. The units are in kilonewton per meter square. So these are actually the diagram for the total stress, and we are now drawing the diagram for the pore water pressure. As we all know that the water present in the pores at least carry its own self weight, and the self weight of the water increases at a rate of a unit weight of gamma W. Hence we can say that the water will carry its own self weight, and hence in the complete 10 meter as the water is present, you can say that in the complete 10 meter the pore water pressure will increase at a rate of gamma W for 10 meter, and hence the pore water pressure will become equal to gamma W into 10. Whereas the effective stress is calculated as the difference of total stress minus pore water pressure. As you can see that for the first 5 meter the value of pore water pressure is same as that of total stress. The difference will be equals to 0, and we can also say that as for the first 5 meter only water is present in the soil, there are no solids for the first 5 meter in the river, you can say that there will not be any stress acting on the solids. As there is no solid, there will be no stress on the solids also, and hence you can say that the effective stress will be 0 for the first 5 meter. But as we see that the effective stress is the difference of the total and pore water pressure, you can easily say that the increase in the total minus increase in the pore water, the increase in pore water is nothing but that is gamma W into 5 for the last 5 meter. The increase will be the gamma saturated into 5 minus gamma W into 5 for the increase in effective stress, and hence you can see that the effective stress will increase by a difference of gamma saturated and gamma W for 5 meter. The difference of gamma saturated and gamma W is known as gamma submerged into 5. We also know that from the previous cases that the effective stress below the groundwater table increases by gamma submerged, whereas the total stress increases below the groundwater table by a rate of gamma saturated, as it is mentioned in the given diagrams also. So the effective stress at this particular level can be easily calculated as gamma submerged into 5, and as we all know that gamma saturated given in the question is 20, whereas gamma W is 9.81. Gamma submerged will be the difference of these two into 5. So it will be equals to 10.19 into 5, and it will be equals to 51 kilonewton per meter square. The answer will be 51 kilonewton per meter square for this particular question, but we should know about the calculation of all the 3 types of stresses in the given soil case. So I hope you understood this particular question, and now we are moving to the next question, which I am taking from the GATE 2003. The question will be visible on your screen and you can easily read it. Meanwhile, I am rubbing this particular question. So let's start reading this particular question from the 2003. It is saying that for the soil strata shown in the figure, the water table is lowered by a drainage by 2 meter, and if the top 2 meter of sand stratum remains saturated by capillary action, even after lowering of the water table, the increase in effective stress at mid height of the clay layer will be. As it is asking us about the increase, we can easily say that the increase is calculated for any term. Increase is calculated as final minus initial. This will be the value of increase, as the final stress should be more to get increased. So to calculate the value of increase, we have to calculate the values of effective stress in the initial conditions and also in the final conditions. But what are the initial and final conditions? As it is saying that the original groundwater table, as you can see in the diagram also, you can see that the initial groundwater table was at the ground surface, that is GS. So for the initial state, we can draw the diagram for the soil. This is the ground surface and this is initial groundwater table. Also below that there will not be any capillary drainage or capillary saturation, as the water table is at the ground surface. But for the next 12 meter of the soil layer, there is silty sand. As given in the diagram, you can see that gamma saturated for the sand will be equals to 22 kilonewton per meter cube. Whereas after that there is a clay layer, and the clay layer depth is 7 meter. The gamma saturated for clay is given as 19 kilonewton per meter cube. So this is the initial condition for the soil, whereas it is also mentioned that after draining the water level falls to 2 meter. So this is the normal groundwater table, but the above soil is capillary saturated as it is given in the diagram also. So this is capillary saturated for the first 2 meter till the ground surface. After that, it is given that for the next 10 meter there is a sand layer. For gamma saturated equals to 22, and after that clay is present. Clay is again of 7 meter. So these are the two soil cases. First one is the initial and second one is the final. So again, to start with the given question solution, as it is given that you have to calculate the increase in the effective stress. So you must draw the diagram for the initial effective stress as well as the final effective stress. But we already know that below the groundwater table, the effective stress increases by a rate of gamma submerged. And hence you can easily say that the initial effective stress will increase by a value of gamma submerged. And hence from the ground surface, the effective stress will increase from the value of 0. And for the first 12 meter, as the soil is silty sand, its gamma submerged will be used. Whereas after the silty sand in the clay, gamma submerged of the clay should be used. As we also know that gamma submerged is calculated as gamma saturated minus gamma W. Gamma W value is nothing but that is 10 kilonewton per meter cube. So you can easily say that the gamma submerged for the silty sand will be equals to 20 minus 10, that is 10 kilonewton per meter cube. Fine. Whereas gamma submerged for the clay will be 19 minus 10, that is 9 kilonewton per meter cube. We are required to calculate the increase at the mid depth of the clay. So we are plotting the diagram till the mid depth, and the mid depth will be at a distance of 3.5 meters, that is the half of 7 meter. So now to start, for the first 12 meter, gamma submerged of the silty sand will be used, and gamma submerged for the silty sand is nothing but that is 10. So for the first 12 meter, it will increase by a rate of gamma submerged, and that is 10. Whereas for the next 3.5 meter, it will increase by a rate of gamma submerged of the clay, and the clay gamma submerged is given as 9. So for the next 3.5 meter, it will increase by 9 into 3.5. Now again, moving to the final case, as it is mentioned in the question that above 2 meter of the soil is capillary saturated. We know that for the capillary saturation, the pore water pressure diagram is negative in the capillary zone, whereas it is positive in the normal water table zone. For the first 2 meter, the pore water pressure diagram will be negative, and that will be equals to 2 into gamma W. Whereas it will become equals to 0 at the normal water table, and then it will increase till the mid depth of the clay. The total depth from this particular layer will be 10 plus 3.5, that will be equals to 13.5 into gamma W. So this will be the diagram for the pore water pressure in the capillary zone. But if we are drawing the diagram for the effective stress, we also know that the effective stress at the top will be increased by a value of HC into gamma W. It will not be 0 even at the ground level, and hence the effective stress will be equals to 2 into gamma W at the top. And below that, we have already studied about this capillary case in the previous videos. So we already know about this particular diagram from the previous cases. You can easily draw the diagram by just copying or just putting the values. So hence we are starting after the value of 2 gamma W below the soil is saturated, the effective stress will increase by a value of gamma submerged, and hence the graph will increase linearly at a rate of gamma submerged, and it will increase to the first 12 meter the soil is sand, and for the first 12 meter gamma submerged of sand will be used, and this increase will be equals to, for the first 12 meter, that will be 12 into 10, whereas for the next 3.5 meter this increase will be equals to 3.5 into gamma submerged of the clay, and that will be 9. From the given two diagrams of the effective stress, you can easily compare the two diagrams and can say that the triangle as drawn in the first or initial effective stress diagram is the same, but there is an extra rectangle portion in the final stress diagram. Final stress diagram have this particular portion extra, and as this portion is extra, you can easily say that the effective stress will increase by a value of 2 into gamma W. And if the value of gamma W is taken as 10, you can say that the increase in effective stress will be equals to 2 into gamma W, and gamma W is taken as 10. Hence you can say that it will be 20 kilonewton per meter square, which can be written as 20 kilopascal. You can easily look at the options, and hence you can easily take out the correct option. So now I am moving to the next question that is similar to this particular question, and first of all let me rub this particular question. Now again I am taking again a new question from GATE 2004. So the question is from GATE 2004, and again you can see that on the screen. The question is saying that a 10 meter thick clay layer is underlain by a sand layer. A diagram is also given in the question like this. The depths are given for the first 10 meter, that is clay. After that sand is present for the next 20 meter. Fine. The water table is 5 meter below the surface of the clay layer. Initially the water table is here. Fine. This is at a distance of 5 meter. The soil above the water table is capillary saturated. Soil above the water table is capillary saturated. That means this particular zone is capillary saturated. The value of gamma saturated is 19. Okay, fine. The gamma saturated given is 19 kilonewton per meter cube. The unit weight of water is gamma W. Fine. It is taken directly as gamma W. If now the water table rises to the surface, the effective stress at a point on the interface will increase, decrease, remains unchanged. Again it is asking us about the comparative value, and hence we have to compare the initial case with the final case. And the final case will be, it is written that if now the water table rises to the surface, that means in the final case the water table will be at the surface of the ground level. So this will be the final case. This top layer will be the clay, and after that the soil will be sand. It is asking as the effective stress at a point P on the interface. Already this point P is also given in the question. It is again asking us about the comparison of the initial and final cases. I have already drawn the cases, initial and final cases, and now I am drawing the diagrams for the initial effective stress and the final effective stresses. We have already studied about the capillary saturation conditions in the previous question also, and also in the previous cases as in the theory of the effective stresses. So now we are directly drawing the effective stress diagrams. We already know that in the capillary zone, the effective stress increases by a value of gamma W into HSE. Here, the value of HSE is nothing but that is, for the first 5 meter only, the soil is capillary saturated. So capillary saturation will be only for the 5 meter. So you can say that the height of capillary rise is nothing but that is 5 meter. So you can say that the effective stress will be equals to 5 into gamma W at the top. And below that, gamma submerged should be used as it was in the previous question. So for the next 10 meter, gamma submerged of clay will be used for the next 10 meter. And hence this will be the effective stress at point P. Similarly, if we are drawing the effective stress diagram, for the final case, it is the case of normal saturation, and we also know that in the condition of normal saturation, the effective stress increases at a rate of gamma submerged. For the first 10 meter, the effective stress will increase by a value of gamma submerged of the clay for the 10 meter, and hence the effective stress will be gamma submerged of clay into 10. But if you are comparing the initial and final effective stress diagrams, you can see that this part of 5 gamma W is now missing in the final diagram. Hence, you can say that the effective stress is decreasing by a value of 5 gamma W. So this will be the solution, or very simple solution for the question that was asked in GATE 2004. All the questions are very easy. And very easy. You have already studied about these particular cases in the theory lectures, and you can simply directly copy those diagrams for solving these questions. It will be very easy if you have clear concepts, and all the exams will be very easy to crack. So now we are again moving to some medium level questions in the next video. Till then, you can enjoy the engineering. Happy engineering!